Okay, so in the previous video, we went right ahead and found the transfer function for an RC circuit. We were particularly interested in the voltage gain. I'm going to be interested in the same transfer function here, V out over Vs, but this is for a different circuit. This is for an RL circuit, so it's going to have a different transfer function. Okay, so let's go ahead and draw the circuit. If we go back, 2 slides, we can see the steps. The first step here says to obtain the frequency domain equivalent of the circuit. Basically says replace RLC values with their impedances, which we found here. And so, of course, the impedance of the resistor and the inductor are what we need here. It's going to be Vs, capital Vs here as a phasor. And then I'll write this as a resistor R. And then I'll write this impedance of the inductor here as J omega L. All right, so that's my circuit there. And then my phasor here will be V out. And of course, this still represents a voltage divider. We still haven't gotten much further along than just these simple circuits, which is fine and dandy. First order circuits are very important, and it's important to be able to derive these transfer functions. So don't worry if this seems very difficult and very confusing. That's okay. If this seems way too easy, that's also okay. That's great. And so let's go ahead and do this. Again, we know that V out is going to be equal to Vs, basically in this case, multiplied by my impedance of the inductor, which is going to be J omega L, divided by the sum of my impedance of the resistor plus the impedance of the inductor. And so I get V out is equal to Vs times J omega L over R plus J omega L. Okay? And so what I can do here is I can divide both sides by Vs. And so I can get my transfer function V out over Vs right here to be equal to J omega L over R plus J omega L. And then I could do a couple of different things here. If I wanted to manipulate this equation, I could either divide the top and the bottom by R. And if I were to do that, I would basically get J omega L over R over 1 plus J omega L over R, which would be fine. I could have also divided the top and the bottom by J omega L, in which case I would get something like 1 over 1 plus, or I guess in that case it would be minus, but it would be 1 plus, I said I would divide the top and the bottom, so it would be R over J omega L, which would be equal to 1 over 1 minus J R over L over omega, or something like that. Yeah, so that's getting pretty ugly, so there's no real reason to go this deep. We can just leave it just like this, and we can say that either given one of these is our transfer function for the RL circuit. Okay, so I guess the process is probably becoming pretty familiar now. It's pretty straightforward how to obtain these once we get this ratio. We can do kind of whatever we want to manipulate it. I guess the key here is that when we get into the next section, which is going to be the frequency response section, we are interested in representing this expression as a complex number, which has a real part and an imaginary part. So from the benefit of getting it into an expression that has a 1 plus something on the denominator side is that we can multiply by the complex conjugate when we get into the next section, and it will lend itself nicely to giving us a complex number that we can work with for sketching the frequency response of the circuit, which is desirable for us. It may not seem that way now, so at this point you might think, oh, what was wrong with just leaving it like this? And there is nothing necessarily wrong, but getting it into a form where there's 1 plus something in the denominator, it just makes the math work out easier down the road, and you'll start to see that in the next section. So for the time being, all we have to worry about is obtaining this ratio. We've done that, and we've done that for the RL circuit. We did it over here for the RC circuit, and so we're pretty much good with obtaining transfer functions. I'm going to go ahead and end this video here, and in the next video, we're going to move into frequency response. So we're done with the section on transfer functions, okay? So let's go ahead and move on.